So as always, we are going to wait for about a minute or two before we get things started, just to give everyone a little bit of time to get in here. So just going to go ahead and wait a little bit as we let people join on in. All right, let's go ahead and get things started. So for those of you who are continuing from the summer classes, we're just going to be going through all the different practice tests in the later portions of the SAT tips and tricks book. For those of you who are new to this class, we spent about 5 weeks or so going through the material in the first 63 tips. And then from there, we're now talking through the different practice tests, and we're going to be showing, how to use those different techniques, right? So as we go through the problems, I'll do my best to remember to mention where each of these topics gets brought up. That's something that I did during the 63 tips as well. I brought up, just like, okay, like this topic, right? This is something that you'll see in geometry or something like that. And throughout the course of the problems, if the topic is something that you'll see in the art of problem solving books, so those are the ones that that we teach here. So the ones that we typically use are like the pre-algebra book, the introduction to algebra, introduction to geometry, right? So those are the books that I'm going to be mentioning as we go through. So if I mention a specific chapter number, that's the book that I'm talking about. So the art of problem solving pre-algebra book, for example, I'll say like, okay, this question mentions a topic that you can find out more there or something like that. So that's kind of what you'll see there. So for today, we're starting with the last practice test. So practice test number 16. We're going to be starting from all the way at the very back, and we're going to be moving our way towards the front. So with that, let's go ahead and get things started. So I have practice test number 16 pulled up, starting with questions from section 3, and we'll be moving into section 4. So the way the SATs is structured is section 1 and section 2 are your reading and writing sections. And then section 3 and section 4 are your 2 math sections. Now, the reason why there's 2 different math sections is because section 3 is a no calculator section, while section 4 is a with calculator section. If there's any question, if there's any kind of questions that I feel like would be better solved using a calculator. I will show you how it's done with a calculator, but that's something for me. I'll show you those once we get around to it. But with that, that's gonna be about it here. So let's go ahead and get things started. So starting things off, problem number 1. So if this is your first time with me, the way that I like to go through these problems is I like to call on people to help me out, and I'd like to see how you guys would answer it, and then from there work it out with you guys, right? So that's the way that I like to approach these questions. So problem number 1, let's start off this week with Jade. Let's start off with you.
Which of the following is an equation of line L in the xy plane above? It has a slope of 2 over 3, negative 2 over 3.
Okay.
The y-intercept is negative 1, so it'd be B.
Did you say B?
D.
This one?
No.
Oh, D? Did you?
Yeah.
Okay, good. Yeah, so this answer choice is D. As you mentioned, right, the slope is negative 2 over 3, the y-intercept is negative 1. And that tells you, okay, well, the equation of my line is y equals mx plus b after all, right? That's the slope-intercept form of a line, where m is the slope and b is your y-intercept. To find the slope, what you could do is you can use 2 different points. For example, I can use 0, negative 1 here, and I can use 3, negative 3 here. And that should tell me, okay, my slope is negative 2 over 3. The reason why is because I can do negative 3 minus negative 1 divided by 3 minus 0, right? Y2 minus y1 over x2 minus x1. And from there, well, my y-intercept is the value of y when x is equal to 0. Okay, I know my answer has to be D. In fact, I actually am done as soon as I find my slope, right? All of these answer choices have a different slope. So that's all I really need to find. I just need to find the slope and I should be good. But that's exactly it. Nice work. So this question, this one is one that you really learn about in the Introduction to Algebra book. I would say this is Algebra 1, chapter 8. This is where you really get to see all of that. All right. Problem number 2. Let's hear from Carrie. Carrie, problem number 2. No Carrie? Okay, how about Ben then?
Okay. The circle above with center O has an area of 36 pi. What is the length of major arc A, B, C?
So when we say a major arc ABC, what does that mean?
Like A, B, and C, like there's 2 arcs, and then like
Well, the point here is like ABC is like the long way around, right? It's the way all the way around this way, right? So that's what we're looking for here. So when we say 36 pi, what does that tell us for the area? Like, what information does that give us?
The circumference, no, the radius is 6.
Right, and that's because the area is equal to pi r squared, right? So if that's equal to 36 pi, then we know that, okay, r squared is equal to 36, which means r is equal to 6. I agree with that. And then from here, what can we do?
You find the area? No.
Well, you already started with the area, right? So it doesn't make sense to go back to the area, does it?
Oh, wait. You find the circumference. I mean, circumference.
Yeah, the full circumference, right? So the full circumference is 2 pi r, which is equal to 12 pi. But that's not the answer that we're looking for, right?
Yeah, it's 3/4, so I think it's 9 pi.
Yeah, so the answer here is going to be 9 pi. And the reason why it's 3/4 is because of the fact that we have 90 degrees taken off, right? So what we have is the remaining 270 degrees of the 360. And if there's a 360 degrees in total and we have 270 of them, that means that we have 3/4 of the full circle. So that's why we take 3/4 of the full circumference, which is the answer that we're looking for here. That's exactly it. So that's why our answer here is C9I. Any questions here from anyone? Any questions between either, this one or problem number 1? So this is something that you should have learned in pre-algebra or so. Like this is something that you should have learned when you work with, just like the equations of circles in general for the first time. I'm trying to find it, but I think this is, I would put this under like chapter 10 in pre-algebra or so. But this is something that you can, this is something that you see a lot more of in chapter 11 of, this is something that you see a lot more of in chapter 11 of geometry. So that's where you find a lot of circle stuff. All right, problem number 3. Ashley, just moving up through the list of names. And if you guys, if for any reason you guys don't want to answer a question, just let me know and I won't call on you. But so that I don't like call on you and then just sit there. No, Ashley. Okay. How about Amanda?
You would multiply everything by 10 so that x squared is has an a of 1.
Yeah, so the idea here is if we multiply through everything by 10, we're going to get a coefficient of 1 on the x squared, right? And that's going to help us out a lot, right? Because that makes things, a lot nicer. We don't have to work with fractions anymore. Also, another thing to consider is division by 2, division by 5. Multiplying by 10 will actually get rid of both of those fractions as well. So if we do that, we'll get x squared minus 5x plus 6 is equal to 0. All right, what now?
And then you just factor it.
Yeah. So at this point we can factor. So when we're factoring, what do we need to consider?
That it adds up to -5 and multiplies to +6.
Yeah. So if it adds up to a negative number but multiplies to a positive one, what kind of numbers do we have?
X minus 2 times x minus 3.
Yeah, so I was going for 2 negative numbers here, but -2, -3 works as well, right? But I do agree with you, x minus 2 times x minus 3. I do agree with you on that, right? And the reason why this works is because, okay, -2 plus -3 is -5, -2 times -3 is +6. That means that we line up to exactly this. But now my question is, well, does that mean our answers are -2 and -3 like A, or not quite?
No, because it's equal to 0, so then that means that x equals 2. Like when you said x in x minus 2 equals 0, then you have x equals 2 and x minus 3. I mean x equals 3.
Yeah, so the idea here is either x minus 2 is equal to 0 or x minus 3 is equal to 0, right? If one of these guys is equal to 0, the product between the two would be equal to 0. But in order for x minus 2 to be equal to 0, that means that x itself is equal to 2. And in order for x minus 3 to be equal to 0, x itself is actually equal to 3. So just because our answers were x minus 2 times x minus 3 does not mean our answers are -2 and -3. It actually means the opposite. Our answers are 2 and 3, D. And this is something that you learn about in Algebra 1. I think in chapter, I want to say 10 or so. So this is something that you learn there. Yeah, so this is Algebra 1, chapter 10. In fact, this is probably the most important topic in Algebra 1. This is, well, one of them, right? So this is one of the most important topics in Algebra 1, understanding how to factor this, right? So this factoring step here, being able to go from, this first step to this one, this is one that you really just have to practice a lot of. There's not really that much that I can tell you here. It's just saying, oh, find two numbers that multiply together to equal +6, add together is equal -5, right? At the end of the day, it feels like you're just doing a lot of guess and check. And to be very honest, you kind of are. But this is something that, you really just need to have a lot of practice with. There is an alternative way to go from here to your answers. And that other way, actually, Amanda, do you know what that other way is? to not have to factor this step, is there any other way that you could have done this?
Quadratic formula.
Yeah, there's a quadratic formula. Do you remember what that is?
Negative b, x equals negative b plus or minus the square root of b squared minus 4ac over 2a.
Yeah. So this actually will give you both of your solutions as long as you can plug in all the different numbers from your ax squared plus bx plus c equals 0 equation. Remember, this has to equal 0, right? So that means that any number on the right-hand side needs to be moved over to the left, right? If I just plug in my numbers, calculate the square roots, add, subtract, I should get both of my answers. Now, the only reason why this method is not very preferred when you're working with, the non-calculator section is because you don't get a calculator. So things can be a little bit more tricky when you're trying to do that square root. But overall, if you're struggling with this method here, this is your cop-out. This will always get you your answer as long as you have the correct quadratic equation to begin with. So this formula will always tell you the two different values of x, but sometimes it might just be one because you might be adding or subtracting 0. But that's what we have here. All right, nice work. Let's take a look at problem number 4. Problem 4. And then as always, right, please start by reading the question. Rebecca, problem number 4. Rebecca? Okay, Nicholas? Also no? Oh, okay. How about Miles then?
Which of the following is a function whose graph in the xy plane has no x-intercepts?
So the first question here that I want to ask is, when you say no x-intercepts, what does that mean?
Nothing touches the x-axis.
Right, which and how would something touch the x-axis basically?
A line goes through it.
Sure. What I was going for here was more along the lines of something like, okay, if I go through the x-axis, that means y is equal to 0, right? So the idea here is I need to find some way for y to be equal to 0. So can 2x minus 1 be equal to 0? If it can, if there is a value of x that makes this possible, that means that this does have an x-intercept, which means that this is not the correct answer, right?
Yeah.
Because the correct answer should not have an x-intercept. So basically, that's what we're doing. We're going through and we're seeing, can this equal 0? So first off, can 2x minus 1 be equal to 0?
It'll just be 1/2.
Yeah. So this is wrong. What about the rest?
So B would have x intercepts of -5 and 2, so or 5 and -2, so
Right.
that'll be incorrect. And then C would have x-intercept of 2.
Will it? If I plug in 2, do I get 0?
Oh no, you get -8. So I guess C is the answer.
Yeah, C is going to be the answer because D, if x equals 1, then this is equal to 0, right? So C is the answer, but we didn't actually have to go through and test everything else. We could have just went ahead and recognized, hey, for C right here, right, -x², for any value of x, that is either 0 or lower, right? There's no way that this number is ever positive because I cannot get a negative number when I square, because then I would have to multiply by that negative to get then the positive number that I'm looking for, right? So -x², this number has to be less than or equal to 0. And if I subtract 4 from it, there's no way that this number will be greater than -4. This number will be less than or equal to -4. So if this is less than or equal to -4, there's no way this is ever equal to 0. So that's why this answer is C. So this is another thing that you guys will see in the Algebra 1 book. I'm going to put this under Algebra 1, chapter 8/10. You have topics coming from chapter 10, you have topics coming from chapter 8, but that's what we see. That's what we really see here. Any questions over problem number 4? All right. Problem number 5. All right, let's hear from Minmin.
In the equation above, k is a constant. If x equals 1, what is the value of k? So you first just write out the equation on your own, and then you
Sure.
subtract 2.
So when you say write it out, are you saying also replace x with 1?
Yeah.
Okay.
Yeah.
Sure.
And then you subtract 2.
Okay. So subtracting 2 brings us to square root of k plus 11 is equal to k minus 1. Is that right?
Yeah.
Okay.
And
So
then
what should we do now?
you get rid of the square root.
Get rid of the square root. How do we get rid of the square root then?
You multiply
What do I multiply?
by itself, I think.
Oh, okay. So you're saying square both sides. Is that right?
Yeah.
Okay. So I get k plus 11 is equal to k minus 1 squared. So we are allowed to square both sides. Just kind of telling you why. The reason why is because you know the left side is equal to the right side. So if I multiply the left side by itself and multiply the right side by itself, I'm multiplying both sides by the same number. So squaring both sides is something that you are allowed to do.
Yeah.
What do we do at this point?
You factor it. So it becomes at k to the second power minus 2x plus 1.
It would be minus 2k, right?
Yeah.
Okay. And that's equal to k plus 11.
Yeah.
Okay.
And
What
then
now?
you subtract 11.
So 0 is equal to, well, I would also subtract k, right?
Yeah.
Okay, so that's equal to 3k minus 10. Okay.
Yeah. And then you factor it. So it becomes 0 equals k minus 5 times k plus 2.
That is right, yeah. And what do
And
you do from
then
here?
And then you do k, so the answer is k equals 5 and k equals -1. Oh, k equals -2.
But we have both of those answers here, -2 and 5. Which one of them is correct? Is it really both of them?
No,
Why not both of them? What's going on?
because it says x equals 1.
It's not exactly why. So the reason why only one of them is correct is actually because right at the beginning you squared both sides, right?
Yeah.
So if I plug in numbers into here, you'll actually see why exactly we get this problem. So if I plug in -2 into this step, I get the square root of 9 squared is equal to -3 squared. So the problem here is I've had one side's a negative number, one side's a positive number, but when I square it, it ends up being the same number. So if I plug in -2, I'll find something that says basically -3 is equal to +3, which we both know is wrong, right?
Yeah.
But if I plug in 5, I'll get 4 is equal to, I'll get 4 is equal to 4 or something along those lines.
Yeah.
So 5 is the correct answer here. -2 is not. And the reason why we got -2 to be a false answer, to be an extraneous solution, is because of the fact that we squared both sides right at the start. And that made us go from, -3 equals +3. That gave us that problem essentially. So that's why we have that issue. Does that make sense?
Yeah.
Okay. So I do agree with you. Every step along the way, I think you did really, really well, right? So this is how you would actually fully prove this. Step by step, this is how you would do it. The only thing you missed was at the very end, going back here, recognizing, okay, only one of these can be correct. We cannot have both of them correct. What that means is we need to plug them back into the original equation up here, test to see which one is right. You'll find that one of them gives you a negative number is equal to a positive number. One of them gives you positive is equal to positive. The one that you're looking for is positive equals positive, right? Now, Min, what if I told you you didn't have to do all this? What if instead I told you, so remember how you got the square root of k plus 11 is equal to k minus 1?
Yeah.
What if I told you right here, you just plug in the values of k? What if -2? Does square root of 9 equal -3? No. What if I plug in +2? Square root of 13 equals 1? No. If I plug in 5, does square root of 16 equal 4? Oh, okay, it's 5. Do you see how much easier that is?
Yeah.
So for this question, it's a lot easier if you just plug in your answer choices into the values of k rather than actually solving it out algebraically. So for something like this, if you're not sure about how to actually do it, right, take advantage of the fact that it's a multiple choice test, right? You're given the possible values of k. If you know one of them is going to make your equation true, just plug them in one by one and see which one makes it right. But that's the idea here, right? Instead of actually solving the whole equation algebraically, which you did really well, you could have just plugged in the values and just did some basic math instead. Like, well, not really basic, but like just did like addition, square roots and stuff like that instead. And that probably would have been a little bit easier for you. But that's what I would have recommended to do here. Just plug in the numbers. But really nice work done here, right? So this is how you would solve it algebraically. This is how, and I would recommend knowing how to do this as well, because you're going to want to be able to do this for other questions, right? But this is, for this specific question, this is the much easier way to do it. So this is something that you'll learn in, I want to say, Algebra 1, chapter 3 or so. This is something that you pretty much work with there. But that's what we see here. Chapter 3, and then like solve, and well, for this part of it, right? So being able to do this, that's Algebra 1, chapter 3. Being able to solve from here and doing, this factoring, that's like chapter 10 and stuff. So you kind of mix some stuff from the Algebra 1 book. All right, problem number 6. Marcus.
All right. Which of the following is? Excuse me. Can you hear me?
Yeah, I can hear you.
All right. Which of the following is equivalent to the sum of a cubed minus 2a and a squared minus 2? So I think you can first write the equation as a cubed minus 2a, or in parentheses, sorry, plus a squared minus 2. Yeah.
Like that? Okay.
And then from there, I think you can factor out in a from the a squared minus 2a.
A cubed minus 2a?
Oh, yeah, a cubed, sorry.
Okay. So that becomes a times a squared minus 2 plus a squared minus 2.
And then I think you can also get rid of a... Actually, never mind. I don't think you get rid of the 2.
Yeah, there's not anything you can do with that. However, there's a repeated term here, isn't there?
Yeah.
So you can actually you can factor out a squared minus 2 from each of these to make this a squared minus 2 times a plus 1.
And then isn't that your answer? Yeah.
Which is C, right? So this is called grouping, actually. This is a method of factoring called grouping. If you're not familiar with this method, instead what you can do is you can just add everything together, right? You get a cubed plus a squared minus 2a minus 2. And then what you'll recognize is, okay, well, from here, right? Well, obviously a cubed minus 2 is not it. And then what you can do is you can just you can just expand out all of your answer choices to see which one is the correct answer, right? So you'll see this one's a cubed plus a squared. Okay, that's also wrong. There's no minus 2a minus 2 part, right? D is a little bit easier because we have this. That's a squared minus 1 times a, that's a cubed minus a. Okay, well, that's also wrong. So that means that C has to be your right answer. We don't even need to actually, multiply out for C. We already know everything else is wrong. So you know that C has to be the right answer. But this is, another way that you could have done this instead of, again, right, kind of like problem number 5, instead of solving for the answer directly, use your answer choices. See which one of those has to be the right one. And that's what we see here. And yeah, so this is something that you see a lot of in, I want to say, Algebra 1, chapter 10, chapter 13, chapter 11, something along those lines. So Algebra 1, chapter, I'll just say 10 through 13 in a sense. You kind of mix a lot of topics here. All those topics are very similar. So that's where this comes from. All right, problem number 7. Luke. Helen. No Helen either. Gracie. No. Okay, how about Eric then? All right.
I can do this one.
Sure.
So Peter has 2 weekly jobs. He works in a town library, which pays $12 per hour. I can associate this 12 with X because for each hour he works at the town library is $12 per hour. So that would be 12X. And then since Y is the number of hours he works as a cashier in the grocery mart, and the grocery mart pays $10.50 per hour, I can associate that with 10.5Y. And then he wants to earn at least $120. So I have to make that equation as 12X plus 10.5Y is greater than or equal to 120. And then it also says he can work no more than 15 hours per week. So I have to make X plus Y is less than or equal to 15, which is D in this case.
Yep, that's exactly it. This is something that you'll see in Algebra 1 in chapter 9. So this is just a basic inequality, right? So it's like, okay, we want to earn at least 120. Okay, that means we are greater than or equal to 120. If we want to, at most no more than 15, okay, that's less than or equal to 15. And that's exactly what D here is. Nice work. That one is pretty quick. There's just a lot of reading there. Do you mind doing problem number 8 as well? I'll read for you here. So a kitchen appliance manufacturing company determines that the total cost C in dollars of producing N units of the blender is given by Cn is equal to 30N plus 2,500. Which of the following statements is the best interpretation of the number 2,500 in this context? Eric, what is it?
I'm guessing this might be the cost of producing 30 units, but I'm not exactly sure here. Because I know I am given that the total cost is equal to, well, and producing, well, this is 30 units of 30 blender units plus 2,500 for the total cost of C.
So remember, the total cost is equal to the total cost C of producing N units is equal to 30N plus 2,500. So for one unit, 30 times 1 plus 2,500. 2 units, that would be 30 times 2 plus 2,500. Do you see where this is going? So the cost of producing 30 units, that would be C30 actually, right? Because C30 represents the total cost of producing 30 units. So the cost of producing 30 units, that would be C30. Does that make sense?
Oh, okay.
And that's not 2,500, right? So what are we looking at then? let's look down each of these, right? So the cost of producing each unit, what is that? If each blender is $2,500, you have a lot of problems, right? There's no way that that's true. So what you want to look at here is you want to look at kind of what this is, right? So what equation is this? If you're familiar with the slope of
This
a line,
is a linear slope.
yeah, this is y equals mx plus b, right? So this is y equals mx plus b, and the number that you're looking for, the 2,500, that is your b. Do you know what b represents in the
Y-intercept.
mx? Yeah, it's the y-intercept. And when we say the y-intercept, what that really means is it is the value that y takes on when x is equal to 0, right? So if we think about it that way, well, then what this means is no matter what value your x is, you have to pay this 2,500.
So it would be C in this case.
That's C, yeah. B, this answer here is Cn, right? You're told the total cost of producing n units is Cn. You've been told that directly in the question. And the cost of producing each unit, that's a huge, huge indicator. Hey, this is the amount that each unit gets multiplied by. That's the $30. So the cost of producing each unit is 30. The total cost that must be paid no matter what, right? No matter how many units you produce, that's C here. That is the 2,500. That's what we see here. Any questions from anyone? All right, nice work. Let's move on to the next page. This is something that you, I would put this under chapter 8, but this is a more of like an interpretation of, so this is like chapter 8 in algebra 1 or so. This is like an interpretation of a line. That's really the idea here, right? So I think something that really helps out here is just like think it through all your different answer choices. Like, okay, well, cost of producing each unit, right? Does it make sense for 2,500 to be that? No, right? Each unit, like if it's cost of each unit, right? That means that the unit number should be multiplied by this number, right? Well, okay, in this case, that's the 30 instead, right? And going through here and going through all of that, right? I think this is a little bit misleading because the 30 units matches up with the 30 here, but what does the 2,500 have to do with that, right? Remember, read through the question. The price of producing n units is this. So the price of producing 30 units should be if n is equal to 30, not the 2,500 at all. Okay, let's take a look at the next page here. We have problems 9 through 12. All right, let's hear from, I think we're on Brandon.
What question am I doing?
Problem number 9. Can you read through the problem?
Trying to think about it. If X is equal to
So if xy is a solution to the systems of equations above, if x is greater than 0, what is the value of x plus y? So what does it mean if it's a solution to the systems of equations?
So it means like one certain number equals like one letter equals a certain number, and then I don't know.
Basically the same xy pair solves both of the equations at the same time. Like we can plug in the same values of x and y for both of the equations. Does that make sense?
Okay.
So that idea means that, okay, well, what that means is we're just going to plug in the same exact answers, right? So, well, what that means is I can go ahead and say, well, if I know that y is equal to x squared, then what can I do with this y up here?
Like put a 2 on top of it or something.
Well, you've been told that that's equal to x squared. So I can just replace y with x squared. Anytime I see y, I can just replace it with x squared. So then my equation becomes 2x plus 12 is equal to 2 times x squared minus 6. Does that make sense?
Okay.
So then what can I do here?
We just need to figure out 2x plus 12. And then we can get the answer. Yes.
There's no way to figure out what 2x plus 12 is equal to. Not directly. No, you can't do that because you don't know what the value of x is. So instead of doing that, what you need to do is you need to distribute this 2 to get the parentheses to go away. So if you distribute the 2, you get 2x squared minus 12 is equal to 2x plus 12. What should we do here? What do we do at this point?
So then we need to know what x is. So we need to.
How do you solve for x here? We've actually seen this already here today. We've seen this in problem number 3, problem number 4, and those two. We've seen this in problem number 3 and 4 already. This is a quadratic. And the reason why we know this is a quadratic is because we have a square term right here. This is something that you'll learn in Algebra 1, Chapter 10. But the idea is in order to be able to solve this, what you need to do is you need to move everything over to one side. So for example, if I move everything over to the right side, I'm going to get 0 is equal to 2x squared minus 2x minus 24. And then from here, now we can go ahead and solve this quadratic. So if you're not familiar with solving quadratic equations, this is the reason why you're not, this is the reason why you're struggling with this question. It's because this is something that you learn about in Algebra 1. So from here, right, this is the quadratic equation that we want to solve. The quadratic equation, in order to solve this, right, it's a lot easier if we divide through so that our leading coefficient, our coefficient of x squared is equal to 1. We can divide through by 2, right? So if we divide through by 2, that's going to make it 0 is equal to x squared minus x minus 12. So does it make sense how I went from here to here, here to here, and here to here?
Yes.
So what did I do in this first step?
You had to get rid of the parentheses.
Right, I distributed to get rid of the parentheses. What did I do from the second to third step?
You move everything to the right.
And what did I do from the third to fourth step here?
I kind of forgot.
I divided everything by 2.
Oh.
Now, the reason why I move everything to one side is another way to explain this is we want, no matter what, if you're working with the equation, you always want all of your x's to be on the same side. So that's why we moved everything to the right. Another way to explain this last step is, we have a common factor of 2, so get rid of it, right? Just simplify it a little bit. Okay, so from here, we can factor this out as x minus 4 times x plus 3. Or if you're not familiar with that, what you can do is you can use the quadratic equation. So negative b, that's 1, plus or minus the square root of b squared, that's 1, minus 4ac. So that's minus 4 times negative 12 times 1, all divided by 2a. So all divided by 2. So that's 1 plus or minus 7 divided by 2. Well, we're told that x is greater than 0. So that means that we're looking for the positive value of this. So x is equal to 1 plus 7 over 2, that's equal to 4. Well, if x squared is equal to y, that means that y is equal to 16. So x plus y is equal to 20. Does that make sense?
Yes.
Any questions here from anyone? So that is the way that we would solve that problem. And again, right, we could have gotten x equals 4 here, right? We were told x is greater than 0. So we know that we need to use the positive value of x here. That's what we can do here. So this is a substitution technique at the very beginning, right? And then after that, we solved a quadratic equation. So this actually mixes together 2 different topics. The first topic is the first topic is chapter 5, where we are, where we make this substitution and are able to solve from there. That's something that you learn in chapter 5 of the Algebra 1 book. But starting from here, solving this quadratic equation, right? These steps that we take here, that is a chapter 10 technique. So a lot of things in the SAT, what you'll notice is they will start to mix things together a lot, right? So they'll take one thing from, they'll take one thing from chapter 4, one thing from chapter 10, right? Something along those lines, right? But what we've seen so far is in all of these questions, right? Algebra 1, algebra 1, algebra 1, algebra. Like algebra is a very, 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 largely recurring theme on the SAT. It's a question type that you're going to see over and over and over and over again, right? So if there's one thing that you learn, right, you want to learn algebra, but don't just learn algebra, because there's so many other questions that you're going to need to take, right? But algebra 1 is one of the huge problems that you're going to see. All right, problem number 10. Hey, I wonder what this is. Once again, algebra 1. All right, Jade, can you help me out here?
If a squared minus b squared equals x and y equals 2ab, which of the following is equivalent to x squared plus y squared? Would you just square a squared minus b squared and then add that to 2ab squared?
So you're saying square this and then add 2ab squared, is that right?
Yeah.
And the reason why is because you know that that's just equal to x squared plus y squared, right? So all I've done is I've plugged in the value of x, I've plugged in the value of y, and I've just, gotten the same thing, right? So, well, what do we do now, though? That's the big problem here, right? What do we do now?
Could we just square everything?
Yeah, just multiply this out, right? So what is this when you square it? So this is something in the format of c minus d squared, which is equal to c squared minus 2cd minus plus d squared, right?
Yeah.
So if a squared is equal to c and b squared is equal to d, that means that this is a to the power of 4 minus 2a squared b squared plus b to the power of 4. Would you agree?
Yeah.
Okay. And what is this squared?
4a squared b squared.
Plus 4a squared b squared. So that means that this guy here and this guy should cancel out and leave you positive 2a squared b squared, right?
Yeah.
So this becomes a to the power of 4 plus 2a squared b squared plus b to the power of 4. What can we expect that should be equal to?
A squared plus b squared squared.
Yeah, that's exactly it, right? Because we clearly know, it's not c, it's not d. We also saw what this was equal to, right? It's equal to this. So b is also wrong. So the only answer choice that could be correct at this point is a. And the only difference between c minus d squared and c plus d squared is it's a plus 2cd rather than a minus 2cd, right? So then since this is a plus here instead of a minus here, that means that we should expect that a is our answer. But that's it, right? So this is something that you'll see a lot of in chapter 11 of Algebra 1. And once again, another Algebra 1 problem. All right, nice work. Let's look at problem number 11. Let's hear from Ben.
Okay. Crap, I forgot.
Can you start by reading the question?
The volume of the circular cone is 33 cubic feet. Was the volume in cubic feet of a right circular cone with half the radius and twice the height of the cone?
So we're looking at cones in both situations, right? So we're looking at half the radius and twice the height. So we aren't actually told what the values of the radius or the height are at all, right? But what we do know is that the new radius is half the original one and the new height is double the original one. Well, do you remember what the formula for the volume of a cone is?
Nope.
So it's actually okay if you don't. And the reason why it's okay if you don't is because So if you actually go to the practice test, right on this first page, it's always right here, right? So if you're ever not sure what that formula is, remember it's right here, right at the start, okay? You only get these formulas. So there's a lot of formulas that you need that aren't here, you know, things like y equals mx plus b, right? Things like that. But there are a couple formulas, and they're usually areas or volumes. So if you're forgetting one of those, you're actually, you know, that's not that bad to forget because you actually get those on the test. So what is the formula here?
1/3 of pi r h, no, pi r square h.
Yeah, so 1/3 pi r squared h, right? So what we know is we've been told, okay, so 1/3 pi r squared h is equal to 33. Does that make sense so far? Okay, so now the new radius is half of the original one, right? So instead of plugging in r, I'm going to plug in r over 2. Does that make sense? So now the question is, what is 1/3 pi times r over 2 squared? And then the height is double the original one, so right? So I'm going to put in 2h here, right? So now the question is, what is this equal to? Does that make sense? So now what we can do is we can multiply out r over 2 squared. That's going to be equal to 1/3 pi r squared times 1 over 4 times 2 times h. Does that make sense? Well, I know that 1/3 pi r squared h is equal to 33, right? So then all of this is equal to 33. So now I get 33 times 1/4 times 2. Isn't that just equal to 33 over 2? So that means that our answer here is A. Would you agree?
Yep.
16.5. So any questions over any step along the way here? So this is actually something that we talked about in a very specific tip. I want to say that this is like tip around 28 to 35. I can't remember the exact number, but this is just a, you know, this is just a basic geometric volume question, right? So we're just plugging in the numbers. Even if you actually did plug in numbers, right? If I said, okay, h is equal to 11. Right, and then r is equal to 3, I could have gotten my actual answer as well, right? I could have said, okay, well, that means that r is equal to 1.5 here, this is equal to 22. You would, you know, you'd have to do a little bit of annoying math, but overall, this isn't too bad. But that's what we see here. But right, so this question here, right, this is just a ratios of area / volume kind of question. That's what we see here. All right, problem number 12. I'll go ahead and start taking on some questions. We are reaching towards the later portions of the class, so I do want to get through more questions than just this. So which of the following is equal to 2 times the cube root of 16? So a couple of things first off. This is something that you'll see in this is something that you should actually learn about very, very early in algebra. So this is either chapter 1 of algebra 1 or chapter 9 or so of pre-algebra. So this is something that you learn about there. Chapter 9, algebra 1, chapter 1 or so, something along those lines. But the idea here is we want to simplify this. Now, what you can do is you can look at the cube root of 16 as equal to the cube root of 8 times the cube root of 2. This guy right here, that's just equal to 2. So this is 2 times 2 times the cube root of 2, which is 4 times the cube root of 2, which is d. That's our answer here. So all we're doing here is we're simplifying this square root, this cube root, right? There's a couple of things that are pretty obviously wrong. B is obviously wrong because 2 times the cube root of 4, how is that going to be the same thing as 2 times the cube root of 16, right? If I divide both sides by 2, are you telling me that cube root of 4 is the same thing as the cube root of 16? Of course not, right? Same deal for C, right? So B and C are blatantly wrong because of those reasons, right? They cannot be true. So the only answers that you're really looking at are A and D, but A is, you're looking at a square root here. How could you go from a cube root to a square root, right? It might seem like it's possible, but that's pretty much, the last thing that should happen. What you could do here is, you could actually cube, 2 times the cube root of 16, cube this, you should find that this is equal to 8 times 16. So if anything else here, when cubed, also gives you 8 times 16, that's also the correct answer. But that's a much, much more difficult way to approach that question. It's much easier to just simplify it this way. Any questions over problem number 12 here? And as always, if you guys have any questions, please let me know so that I can answer any questions that you might have. If you guys, don't want to ask in front of everyone, please just send it directly to me and I will answer, I'll read out the question so that everyone knows what question I'm answering, but I won't say who it's from. Problem number 13. Let's continue on here. Actually, Alex, can you do this one?
At a coffee shop, the coffee urn has a certain amount of coffee in it at the start of the afternoon rush. It is filled by adding K coffee bags to hot water. If A coffee bags are made by K coffee bags is given by the equation A equals 10K plus 5. How many additional coffee bags are needed to make each additional 20 cups of coffee?
So A is the number of cups. You want A to increase by 20. So how many additional bags do you need?
Would it be 10K plus 5 equals 20?
That's actually not going to be it, right? Because remember, that's not saying how many, the question is not how many coffee bags do you need for 20 cups. The question is how many additional bags do you need for an additional 20 cups?
So greater or equal?
That's still not quite true. It's rather what you should be thinking about is think about like A2 minus A1 equals 20. What's the value of K2 minus K1? That's what we're really looking at here. So rather, the question is saying like, okay, if A2 is equal to 25 and A1 is equal to 5, what's the value of the different K value, the differences in the Ks? That's what you're really looking for here, right? Because when I say, A is equal to 20, right? That's not true because at the very beginning, right? A starts at 5. When K is equal to 0, when I put in 0 extra bags, I already start with 5 cups because there is already some amount of coffee in it, right? So that's why I cannot say A equals 20. I need to find the difference in A rather than A equals 20 directly. Does that make sense?
Mm-hmm.
Because of the very, very key word additional here. That's the big difference here, right? And this additional word, what you can do here is you can think of this as, this is just a slope question. How many additional bags, right? How many additional bags do we need to make an additional 20 cups, right? So that means that A needs to increase by 20. In order for A to increase by 20, what does K need to increase by? That's what this question is really saying here.
2.
Right. It needs to increase by 2. Because here, this is K equals 2. This is K equals 0. So that's what we have here. So 2 is the right answer. And this is really just a slope question. This is again, chapter 8 of Algebra 1. I would put it there, right? This is really just asking you what's the slope. Any questions here from anyone? All right, problem number 14. Jackson drives an average of 300 miles each week. His car can travel an average of 25 miles per gallon of gasoline. Jackson would like to reduce his weekly expenditure on gasoline by $8. If gasoline costs $2.50 per gallon, how many average miles should he drive each week? So what we are told is we want to reduce the expenditure by $8. And if gasoline costs $2.50 per gallon, we need to figure out first off, how many gallons of gasoline he needs to stop buying, essentially, right? So in order to reduce by $8, that's going to be $8 divided by 2.5. That's equal to 80 over 25. That's equal to 16 over 5, which is equal to 3.2 gallons, right? So we need to reduce our expenditure by 3.2 gallons. So how many miles is that? Well, in order to do that, we can do 3.2 gallons times 25 miles per gallon. So multiplying those two out, that gives us, well, 3.2 times 5 is 16 times another 5. Well, hey, that's 80 miles. How nice. Right? Because that's exactly the number that we divided by back here, right? So recognizing that should save us some time. Okay, so if we reduce our driving by 80 miles, we will reduce our expenditure by $8. And that means that our answer is going to be equal to 220 miles, or B, right? Because we started with 300 miles, reducing it by 80 miles will be our answer here. This is something that you learn both in pre-algebra and in algebra 1. I'll put this, I would say that this is in chapter 6/7 of algebra 1 and chapter 7 in pre-algebra. So this is something that you do see in both of those books. Any questions over problem number 14? Problem number 15. Amanda?
The function f is defined by the function above. Which of the following is a graph of y equals f of negative x in xy plane?
So let me just write out f of x equals the square root of x minus 1. So which of these is f of negative x?
I think it's B, because
What makes you think it's B?
Because you take the actually I think it might be C, because
well, what you can do is you can plug in the value of x, right?
I think
If I can plug in the value of x and see what my what my equation should be equal to, that should tell me an idea of like what I should get, right? So you can see in all of A, B, and D, I plug in 1 and I get 0, correct?
yeah.
So if I plug in 1 and I don't get 0, I'm going to know that C has to be the correct answer, right? So I can say y equals f of negative 1, right? That means that I'm looking at, okay, well, that's equal to the square root of negative 1 minus 1, which is equal to the square root of negative 2. That should not work. That does not give me a number. So that means that C is my right answer if I just plug in 1.
Okay.
Does that make sense?
Yeah.
Yeah. And then, you could plug in all sorts of different numbers, right? You could plug in a lot of different numbers just to check, right? I could plug in negative 1, see if I get 0. I could plug in, positive 2, see if I get negative 1, positive 2, see if I get positive 1, like there's all sorts of different things that I can do here. Does that look good to you?
Mm-hmm.
But the idea is what I can do is I can simply just plug in an x coordinate into here, and I can see what number I should be getting. And if I don't get that on the y coordinate here, I know that that answer choice is wrong. Does that make sense?
Yeah. Okay.
So that's the answer of, just use your answer choices, right? But there's another way to do this. This equation of square root of x minus 1, that's going to look like this. Y equals f of negative x, that is a reflection across the y-axis. So that's why C is correct, because it's reflected over y-axis. D is incorrect because it reflects in the wrong spot. B is incorrect because it reflects vertically instead. And A is the exact same thing as what we started with, which is clearly not going to be true, right? So that's why that's another way that you could have gotten that C is the correct answer. So this is something that you learn about in Algebra 1, I want to say chapter 16 or 17. I want to say chapter 17. But that's what we see here. All right, problems 16 through 20. Problem number 16, Miles.
Claire plans to go on goats and amuse park. The entrance fee costs $8. Each ride costs $4. Claire wants to spend no more than $35 in the park. What is the maximum number of rides for which Claire can take in the park? So we can start by making an equation. So it'll be 8 plus 4x is less than or equal to $35. And we solve for x. So 4x is less than or equal to 27. And then x is x is 6.
Well, x is less than or equal to
Or less
6
than to,
and
yeah.
1/4, right? So the answer here is 6, right?
Yeah.
I agree with you here. And then this is something that you'll see in chapter 11 of Algebra 1. This is just a basic inequality. You do also see this in chapter 5 of pre-algebra. That's kind of where you see that. Okay. Problem number 17. Minmin?
So if p is greater than 1, what is the solution of the equation above? So I think you first have to get rid of all the parentheses, and then you so it becomes 8p minus 8 equals 5p to the second power minus 5 minus 6p plus 1.
6p plus 6, actually.
Yeah.
Because you have to multiply that by the 6 here as well.
Yeah.
Okay. What now?
And then you move all the numbers and p's into like all the same side, I think.
Sure.
So you add 8 and 8p.
Subtract 8p, right?
Yeah.
Okay. So this becomes plus 1. Add 8 becomes, that means plus 9. So this becomes 5p squared minus 14p plus 9 is equal to 0. Okay, what now?
And then you divide 5.
You could or you could just go ahead and directly use or you could just directly use remember the quadratic formula?
Yeah.
Well, so the reason why I'm saying like you should not really look to use you should not really look to divide by 5. The reason why I'm saying that is because if you divide by 5 here, divide by 5 here, it creates fractions that are pretty annoying to work with. So that's not something that's really great to do. So quadratic formula here might be a little bit better. You get 14 plus or minus the square root of 196 minus 4 times 5 times 9 divided by 10. Does that look good to you?
Yeah.
Which is 14 plus or minus the square root of 16 over 10. So that's 14 plus or minus 4 divided by 10. So our answer here is
18 over 10.
Which is 1.8 or 9 over 5.
Yeah.
So you cannot actually enter in 18 over 10 into the answer key into your answer sheet. The reason why is because it's not a simplified fraction. So when you do that, you always make sure it's a simplified fraction, but 9 over 5 is the correct answer here. So this method does work. Expanding out, doing all this, right? This is a correct way to do this. And I would agree with you. Yes, this is definitely one way to do this. However, Minmin, this is a lot more difficult than what you needed to do. Because right away, can you tell me if there's anything that everything here is divisible by? What if I said 5 times p squared minus 1 is actually 5 times p minus 1 times p plus 1? Now do you see a common factor between all 3 of these things?
Yeah.
The p minus 1, right?
Yeah.
So if I divide through by p minus 1, I get 8 equals 5 times p plus 1 minus 6. 14 equals 5p plus 5. 5p equals 9. That's a lot easier to get to 9 over 5. Would you agree?
Yeah.
Yeah. So this is a much quicker way of doing it. But being able to do this means that you need to recognize right away that this guy is the same thing as this, and that you can divide through by p minus 1. I do agree with you here. This is a correct way to do this. But from here, right from here, I would have already said, just go ahead and use the quadratic formula here. It's a lot quicker this way. But this is this is what we have here. So to solve this, there's a couple things that we needed to do. First off, this method here requires you to recognize that p squared minus 1, that's something from chapter 11 of algebra 1. This technique here does not require you to do any of that. This technique takes a lot longer, but this is something from chapter 10 of algebra 1. It's a lot easier to be able to just, use the quadratic formula whenever it's up. But this one saves you a lot of time. That's what we see here. Any questions over problem number 17? So as we saw, 2 different ways to do it. One way takes a lot longer, but we don't need to recognize anything. One way is a lot faster, but if you miss the key points, you're not able to do it that way. All right. Problem number 18. Marcus.
The systems of equations above a solution A, B. What is the value of B?
Mm-hmm.
So I'm assuming B is y, so I guess we just solve for y.
Yeah, so we're just looking for the value of y, right? So this is x comma y. We're looking for the value of y, essentially. All right, how do we solve this?
They give you the conversion, and it's 1/3 y equals 9x.
Mm-hmm.
And in the equation above, there's 3x. So you can convert it to, I think, 1/9.
So you're saying 1
1/9.
over 9y is equal to 3x. Is that what you're saying?
Yeah.
Divide both sides by 3. And then from there, what you're saying, okay, well, 3x is equal to 1 over 9y. So we plug that in right here, right?
Yeah. So
this is called substitution. Yeah. Sorry, 1 second. This is a chapter 5 technique from algebra 1, but that's what we see. That's what we see here. Okay, so you're saying that this becomes 1 over 4 times 1 over 9y plus y is equal to 15 over 8. Is that right?
Yeah.
Okay, what do we do now?
You would just distribute the 1/4 to everything in the parentheses.
You could, or you could multiply both sides by 4.
Oh yeah, to get rid of
over
the
2.
fractions.
Mhm.
And
What
then
now?
from there, I guess you just plug in like numbers to see, or you can just like subtract y from one side, I think.
You could, or you could say, hey, this is the same thing as 10 over 9y is equal to 15 over 2. Multiply both sides by 9, divide both sides by 10.
I think you would get, is it 0.5 or 0.25? Wait, no. You get 6, I think 6.75.
6.75 seems about right. Yeah, 27 over 4, which is 6.75, right? All right, so the last step here, right, combining these two to get you 10 over 9 and then multiplying both sides by 9, dividing both sides by 10 is the best bet here. But yeah, this is a chapter 5 technique from algebra 1, chapter 5, and chapter 4, I guess. But that's what we see here. Chapter 5 and 4. All right, any questions over problem number 18 here? All right, so that first step here, right, Marcus, that's the most important one, being able to substitute in for 3x and the reason why we do that is so that we can remove all the references to x, right? So that we only have y here. We only have a single variable left, right? We don't want both of them. That's the reason why we did that. And then from there, right, we took care of the rest. That's what we saw here. Problem number 19. I'll do 19 and 20 here, and then we'll start asking people again for the next couple problems, for the first couple problems in section 4. The expression above is equivalent to 3x plus 2 over x plus 2 squared, where a and b are constants and x is not equal to 2. What is the value of b? So what we can do here is we can recognize that a over x plus 2 minus b over x plus 2 squared, what that's going to be is the same thing as a times x plus 2 over x plus 2 squared minus b over x plus 2 squared. This is just adding fractions, right? And the reason why this is, this works out this way is because otherwise, right, we are not able to add these two fractions together. They have different denominators. So in order to add together the two fractions, I need to get the common denominator, which is x plus 2 squared, which means I need to multiply this guy by x plus 2 on both the numerator and the denominator. So this gives me ax plus 2a minus b divided by x plus 2 squared, right? All I've done is I've distributed right here. That becomes this, right? And I've added the two together. Well, from here, I can recognize, okay, well, this means that ax is equal to 3x and 2a minus b is equal to 2, right? And the reason why that has to be true is because this is the only piece that has x. This is the only piece that doesn't have x. So the pieces that have x need to match, the pieces that don't have x need to match, which means that we're looking at, well, that means that a is equal to 3. And if a is equal to 3, then that means 6 minus b is equal to 2. That means that b is equal to 4. And that's our answer right here. B is equal to 4. So this is a technique that you should see in, I would put this under chapter 4 of Algebra 1. But the idea here, the fundamental idea here is really behind the addition of fractions. That's something that you actually see more of in the pre-algebra book. I would put this under Algebra 1, chapter 4 and chapter 2 actually. So chapter 2 and Algebra 1 as well. But that's kind of where we see this kind of idea a lot of. The hardest part of this, I think, for some people is actually this last step. When I say, okay, well, this is what I have, right? Well, how does this match up with 3x plus 2? And once I say it, it makes so much sense. It's so, it's so obvious, right? Once I say it, oh yeah, that just means ax is equal to 3x and, 2a minus b is equal to 2. Once I say it, it seems so obvious, right? But before you say it, sometimes it's just a little hard to make that connection. And that's just because for some people, right, they've never seen this before. They've never seen a question like this before. But that's all we're really saying. It just means the parts with the x need to line up, the parts without the x need to line up, right? If I told you ax plus b is equal to 5x plus 4, you should be able to tell me right away, okay, a is equal to 5, b is equal to 4. That's the idea behind this. And that is something that we should have talked about in one of our tips as well, actually. But that's what we see here. And lastly, problem number 20. In the figure above, line L is parallel to line M. What is the value of K? So for this question, there's a couple things that you can do. First off, you want to extend some of your lines, actually. So if I extend line M here, extend line L here, right? That should give us a little bit more information to work with. A couple things right away. First off, this angle right here, that's equal to 180 minus 118, right? Which means that that angle is equal to, well, that should be 62 degrees. Well, if I draw a third line right through the middle that's parallel to both of these lines, what I'll find is that this angle right here is equal to this one because of alternate interior angles. And these two angles are equal because of alternate interior angles. So this one here is also 62 degrees, which means that this one up here should be 39 degrees, which means that K is equal to 39 degrees. You'll actually see pretty much this exact problem in chapter 2 of geometry, of the geometry book. And the idea here, the reason why we need to introduce this line in the middle is because in order to use alternate interior angles, in order to be able to do that, we must have a parallel line through any angles that we use. But the problem is this angle here in the middle doesn't have that. And in fact, there's no transversal that crosses through both lines either. Right? Like there's no transversal that crosses through L and M. So what do? Make this point right here, the one where the two lines kind of stop at, make that a new parallel line that we get to work with. And that gives us a lot more information that we can use. That's what we see here. But again, right, this is in chapter 2 of the geometry book. I want to say 2.4. That you pretty much see this exact problem. So 2.4 is where you see this. Any questions over either problem number 19 or problem number 20? So that moves us on into the calculator section. So for the calculator section, there's a lot more that we get to do. You know, we get to use a calculator after all. But in here, if I find any question here that I feel like, you know, we could solve a lot easier by using a calculator, I'll show you how to do that with a calculator. I will show you with the TI-84. That's the one that I find a lot of schools tend to use, so that's why I'll be showing with that. You know, hopefully, if you guys find the tools on it useful, you guys could, you know, always get one of those, right? They always go on sale right around when school starts. So you find it, you know, if you find it useful, that's probably when you know, look to get one around then. All right, problem number 1. Eric, problem number 1.
All right, so it asks, according to the graph above, which of the following 2 consecutive years has the greatest rate of change in the population for the country? So it's kind of so here I'm guessing there can be both positive and negative rate of change. So looking at the graph, I can see 2013 and 2014 appears to have the greatest rate of change here.
Yeah, greatest rate of change simply just means the greatest difference between 2 consecutive years, right? We're just looking at the greatest, you know, the greatest, because it's y2 minus y1 over x2 minus x1, right? But if we're looking at consecutive years, what that means is, well, that's just x2 minus x1 is 1, right? So I'm just looking for the greatest difference between 2 years. And that's 2013 to 2014. I dropped 30 million compared to, you know, any other year, any other 2 consecutive years. There's no years that have a difference anywhere near that much, right? So that's going to be C, 2013 to 2014. I agree. That one was pretty quick. Do you mind doing another one here for problem number 2?
I mean, I could try this one at least.
I'll read for you first. It's a little long. The Sunny Information and Telephone Company, SITC, calculates a customer's total monthly cell phone charge using the formula above, where C is the total cell phone charge, R is the tax rate, and M is the number of minutes the customer used that month. Last month, a customer used 6 hours, 40 minutes, and paid $54. If the customer uses 8 hours this month, which of the following will be the customer's cost this month? So this question is pretty similar to the other one that you did, right? The one with the C of n is equal to 30n plus 2,500, except in this question, you've been told what each of these numbers mean. Instead, what we're doing is we're trying to find out exactly, you know, what cost it would be, right? So what can we do here? Eric, what can we do here?
I mean, could we plug in the numbers at least?
Yeah, you've been told, right? 6 hours, 40 minutes was $54. So let's plug that in as an equation, right? So C equals 10 plus 0.1 times M. What does M stand for again?
The number of minutes.
Right, so the number of minutes for 6 hours, 40 minutes, we got to convert that into minutes, right? 6 hours is 360, 40 minutes on top of that, that's 400. So that times 400 plus times 1 plus R. Well, we actually know that the cost was $54, so let's plug that in as well, right? So we get 54 is equal to all of that. This is equal to 50. So what is 1 plus R equal to? If 50 times 1 plus R is equal to 54. Eric?
I'm still thinking about this. It's a little confusing.
It's okay, it's okay. So what you can do here, right, is what you can do is just divide both sides by 50, right? You get 54 over 50 is equal to 1 plus r. Does that make sense?
Oh, yeah.
Yeah, that's all we have to do, right? So then from here, right, now we're saying, okay, well, instead of 6 hours, 40 minutes, we're using 8 hours now, right? So that means that now we're looking at 10 plus 0.1 times 8 hours, that's 480 minutes, times 1 plus r, which we saw was 54 over 50. Does that make sense?
Yep.
So that's going to be 58 times 54 divided by 50. And then here, you can just plug this into your calculator, and you can find that this is going to be B. Does that make sense?
Okay, yep.
That's exactly it. Any questions here from anyone else? That's exactly what we're looking at here, right? So this is pretty much exactly it. So this right here is, I would say, this is really just solving for this is really just solving for a variable. You're just solving for 1 plus r. This is something that I would say you would see in both pre-algebra as well as algebra 1. I would say that this is chapter 3 in the algebra 1 book, or chapter 5 in pre-algebra. That's where I would place this. Both of those techniques there. This one is a rate of change question. Rate of change is something that, again, you learn about when you're graphing, and graphing is chapter 8 of algebra 1. So again, another thing from graphing there. I would put that there. Okay, let's try to get at least 2 more in here. Problem number 3. Actually, I'll just work out these last two. Some values of the quadratic function g are shown in the table above. Which of the following defines g? So first off, right away, because you know that if x is equal to 4, g of x is equal to 0, and if x is equal to -3, g of x is equal to 0, I know that I have 2 zeros right away, right? My 2 zeros are x equals -3 and x equals +4. For those to be my 2 zeros, that means that I need to have x plus 3 times x minus 4 in my equation. Right away, I know that this needs to be true. So that means that I know that B and C are wrong right away. I know that I have to be either A or D. Now for A or D, I'm going to need to use this 1, 6. So if I plug in 1, I need to get 6 back from G. So this means that I am doing 4 times -3 times something times, let's say, k is equal to 6. Well, 4 times -3, that's equal to -12. K should be equal to -1/2 in order for this to be equal to 6, which means that my answer here has to be D. Now, this is something that you'll see a lot of in the quadratic section of the Introduction to Algebra book. I would put this under chapter 14 of algebra 1, but that's where you would see this. And probably our last question for today, problem number 4. 2½ cups of flour, 3 eggs, 4 tablespoons of butter, and 1 3/4 cups of sugar. The recipe, which makes a pan of 24 cookies, lists these items above. Peter can only buy eggs by the dozen. If he wants to make a pan of 125 cookies for his birthday party, what is the minimum number of dozens of eggs he should buy to make enough cookies? So first off, in order to make 125 cookies, Peter needs to make 6 batches, right? Because 5 batches will be 120 cookies, right? So he needs to make, a little bit more than that. So he needs to make somewhere between 5 and 6 batches. 5 to 6 batches. We don't need to be exactly precise. We'll just kind of have a general idea for now. Well, what this means is around here, that means that's, 3 eggs, right? 3 eggs times somewhere between 5 to 6 batches. Well, you're looking at somewhere between 15 to 18 eggs, right? Hey, we're good. That's, no matter what, that's less than 24 eggs, which is 2 dozens. So we need 2 dozens, A. Right? So this question here, you could have gotten exactly the correct answer, right? You could have done 125 divided by 24 times 3 to get the exact number of eggs that you need. But just getting at a general idea, okay, we're looking at somewhere between 5 to 6 batches, 15 to 18 eggs, somewhere around there. Okay, that's what we have here, right? But this is another way that you could have done this question. This is something that you'll see in the ratios and proportions section. This is something from chapter 7 of the pre-algebra book, or chapter 6 or 7 in the algebra 1 book. But that's what we see here. So starting from next week, we're going to continue on for next week, we're going to continue on through the remainder of the problems in this section. We're going to go through the rest of, problems 5 through, I think, 38 or 34. But we'll be going through the rest of these problems there. So with that, if you guys don't have any questions, then that's going to be it here for this week. Yeah, problem number 38. And next time around, we're going to finish up the rest of this practice test. If that's all that's going to be all that we have here for today. So with that homework, go ahead, finish up the rest of this test. If you haven't, if you have, you guys can go ahead and get things started with the next practice test. So test number 15. That's what we're going to look at 2 weeks from now. But with that, that's going to be it here for today. And I'll see you all next week.
Bye.
Yeah, for sure. Bye.
Thank you.
Thank you.
Yep.